All right, we are going to go ahead and kick off. So welcome to everyone who is joining. We appreciate you all taking some time out of your day to join us for today's webinar. Today's webinar is actually part of a series that we are rolling out. It's part two, called Unlocking BigQuery. And in this webinar, we are going to be focusing on optimization opportunities in BigQuery, specifically around costs and managing costs. And we want to first start off with a poll. So the poll question is, how effective is your organization at monitoring monthly costs for BigQuery? And as you're answering that, I will also mention if you have any questions, please drop them in the Q&A today. We will be trying to monitor the Q&A chat function just to make sure that we're able to answer those questions. We will have a live Q&A session towards the end of this webinar if time permits. So if you have any of those questions, just continue to drop them in there. If there are any questions that we're unable to get to, we will definitely follow up with y'all on those. We'll let the poll just run a little bit longer, but while we are doing that, we will go ahead and jump into today's agenda. So for today's agenda, we will actually be doing a quick introduction, so introducing today's presenter, which I'm very excited about. We will also dive into what this webinar is about, so cost challenges, optimization solutions, as well as advanced cost controls, and then recommendations that you can kind of take back following some immediate steps or long-term steps that you can kind of implement. From there, we will also provide some InfoTrust resources as well as some additional materials that you may want to sign up for, especially the next two parts of the series for visualization reporting and insights with BigQuery, as well as AI-driven data activation with BigQuery and Vertex AI, which those are very exciting as you continue to think through advancing your analytical needs. So to start off, a little bit about InfoTrust. InfoTrust is a digital analytics and media enablement solutions company focused on privacy-centric solutions to help drive measurable business outcomes for your organization. We do work with many leading industry brands, recognizable brands, on a day-to-day basis. You can actually see all of the other industry brands that we do work in. So we have a wide variety of knowledge across those industries, and we love being able to share those and help our clients continue to advance in their analytics maturity, as well as media enablement capabilities. With that, we also have our capabilities listed out there. So we work with more than just analytics now. Obviously, we can help with media enablement. We can make sure that you all are set up for best government practices, governance practices, I should say. And things along those lines. So if you're looking for any assistance with any of those, definitely feel free to reach out. But today we will be talking about BigQuery. And with that, my name is Jared Fisher. I'm a lead digital analytics specialist here at InfoTrust. You might have seen me before. I like hosting some of these webinars and being able to invite some of my expert colleagues in various areas to join and actually presenting some of these leading topics that are top of mind for a lot of our clients. And today, I actually have the pleasure of Trish joining us today to discuss today's topic. So with that, Trish, I'll go ahead and pass it over to you.
Thank you so much, Jared. Hi, my name is Trish. I am a senior advanced activation analyst. I work on BigQuery day in and day out and practically dream about BigQuery now because that's how much we are going into these projects. So while using BigQuery. So let's talk about the cost challenges while using BigQuery. So if you think of BigQuery, it is really like a superhero. If you have worked on BigQuery, you know that serverless, fully managed enterprise data warehouse. You don't need to have any infrastructure management at all. You can analyze terabytes, petabytes, data in seconds. It's pretty flexible to use it. And it's mainly used for data analysis. Other superpowers that I can really think of is, of course, there's lightning fast queries, which has, distributed analysis engine. You have parallel processing across multiple nodes. It can handle structured and unstructured data, which is great, but it also has multi-cloud flexibility. So if you have your data in Azure or if you're working on AWS and you want to query across all these different platforms, you can do that within BigQuery too. There's no expensive data migration cost. So it's really pretty simple to use, and you are able to pull data from different sources in BigQuery. On top of that, there's a lot of ML capabilities. So if you think of using BigQuery ML, using just SQL, you do have that means to do within BigQuery. So it's really easy to deploy ML models directly in there using SQL and start using those machine learning models. But with great power comes great responsibility, as Uncle Ben said in Spider-Man movie. We have to make sure that we are very careful while using this tool. When we see across all our clients, majority of the expenses is amounted to BigQuery. About 50% of your Google Cloud bills is in BigQuery. And even within that, you can see almost like 85 to 90% of that cost is of compute cost. Only a fraction of that is for the storage prices. And that's why it's even more important that we understand how to optimize query processing, how to make sure that we are using the best practices and reading as low rows as much as possible. And with the data growth, as and how the volume increases, it's going to be even more challenging that we kind of need to like monitor the cost, make sure that we are using this tool efficiently, and we are optimizing every way that we can. So let's talk about a little bit of breakdown, like cost breakdown. It has free tier at the very beginning. So if you look at compute, the first terabyte is free for processing each month. On storage side, it's 10 GB per month, which is free. After that, if for querying you use additional TBs, it's $6.25 for each TB that you're processing. On the storage end, it's variable. So by default, there will be like $0.02 for your active storage, meaning if you've touched that data, if you've updated that data or used it for processing in the last 90 days, it is termed as active storage. And then you are billed $0.02 for that, like per GB for per month here. But if you don't use that data for the last 90 days, it goes and it categorizes itself into long-term storage, and your cost drops by 50%. So you're just, costing like $0.01 per GB per month. And you can go to this link in the deck that we have, and basically it will navigate you to a interface which can calculate your cost according to the data that you have on your project. I highly encourage you guys to also have your BigQuery instance opened up during this presentation and then just try certain things on your end too. So let's go through some optimization solutions. So there are a number of things that we can try on our end. If you want to open up your BigQuery interface and try that same thing on your end, just to see where those options are, you can definitely go through that. So the very first thing that comes to my mind is like how to really how to practice those better querying skills. There are a number of things that you can do in terms of queries. So let me go through some of those in detail. So if you use partitions table, and I'll be talking about GA4 data here a lot because that's the one that we use a lot here at InfoTrust. So in those tables where we have events data or sessions data table, we use table suffix in the where condition for selecting time frame. And when you use that, you'll see automatically how, we have reduced amount of rows being scanned. And we always like have that particular wildcard entry in the table name. Also, whenever you try to query, we should avoid using star wherever possible because BigQuery is columnar database. So it matters how many columns you have in your query. If by any chance, if you can limit the amount of columns that you can add in your query, that would definitely lower the cost. If you have limit clause in your query, it wouldn't, affect in any way the amount of data that is being read. So I would say, let's not use the limit clause at all in our queries because it really doesn't do much of, processing efficiency here. There's also table sample techniques, which are pretty useful. So if you're, in the development phase, you don't want to have entire table being read, you just want to see how the data looks like. In your queries, you can use table sample. You can also use approximate functions like approx count distinct. If you have very large tables and you're doing large aggregations. Also, if you want to just preview the data, there is a tab for you to see all the data in there. You don't have to run queries to just explore and preview your data. And if there is any aggregation done, like in your dashboard, for example, if you have monthly charts or if you have something which is week by week, you can pre-aggregate that data in another table and then pull that into your dashboards rather than directly reading it from the table. So these are some of the ways to save your cost in terms of querying. But there are certain plugins that are also going to be useful. So there's this cost estimator plugin, which I have downloaded to just see how much it would cost me to run this particular query. So let's go through a demo actually. So if we go through BigQuery interface here, and I've just added one sample data set, sample UA data. So in here top, you can see like we have a number of days here for 2017, 2016, and we have a whole lot of data being added here. So if I query this, and if I say, we have star added in here, you can see at the very corner here, it's 15.86 MB and the cost is almost zero because, the first TB is free here. But as in how you if you remove this limit clause, it will still read the same amount of data from your table. If I try to just have one column added, you can see how the data automatically has reduced and it's only 24 KB now. But if you want to further, if you are working with different date ranges, for example, you can just have star added in here. In that case, what it will do is it will try to find GA sessions anywhere within this data set, and it will try to query all the data within that table. So now it's reading 2017, 2016, every, all the years data, and you can see how, the data looks like here. So it's estimating how much you will run every time you have a query written here. So let me add star here again. So you can see if in total, if you have this version of query, it is going to scan a lot of data. It's going to have a lot of rows being processed, and it's about 5 GB here. But if I want to limit and say where table suffix, and this is useful for these kind of, tables. So I'll just have one particular date being added. Here is an example. Let me pull it from here. Okay. So I've added one sample date here, which is present in this table, and you can automatically see that it's reducing the, data being processed. But at the very same time, if I say where data date is equal to the same value, here at the very top, it will still run the whole table and it will, almost process about 5 GB of data. This is to say that whenever you have these kind of tables, you should always use table suffix and not have where clauses, so that you can avoid scanning all the rows in your table, and only reference certain parts of your table. Again, you can now see it's 5 GB, so the whole table is being read. So always try to use table suffix wherever you can with these analytics tables that are structured this way. So once you add that, and if you feel like, okay, I really want to not use the whole rows, I just want to, sample some of my data, so I can use this particular syntax, which is table sample system 1%. So as soon as I add that, it will it will select only certain percent of your data, and then it will try to run your table, your query on top of that. So these are some of the ways that you can optimize your costs. This is definitely very useful in the development stage. This is definitely necessary, like table suffix, when you're running the queries. Um, so to minimize the number of rows, but these are some of the techniques that you can use in BigQuery. And of course, the cost estimator plugin is pretty useful. I've downloaded it here. It always gives me how much it will cost me to run this particular query. All right, so let's see some other techniques here. Now, this one is very important. It's partitioning and clustering the tables. By default, wherever I find this opportunity, I try to implement partitioning, because what it tries to do is it will shard your table in a way that it will only allow you to read some size of your table if you've partitioned it on certain keys. Minimum, if you're using GA4 table, we try to do it on event date or on event timestamp if it's a large data set. This will enhance, the data retrieval and reduce your cost overall. If you can apply clustering, that is like, even more sharding of previously sharded data, and you can apply it on any string type of column, let's say user pseudo ID or event name in there to optimize your query. If you have any other fields like landing page, page path, which is not available within GA4 data, you can, pre-process it, load it into your table, and make sure that you have that available here. Now let's go to an example of what I mean by partitioning and clustering. So if you have a table here, for example, if you don't have anything applied here, we can just have like rows in here, which will kind of have each row here scanned in case you write any query. So right now, if you say, select star this table where date is so-and-so and my country is so-and-so, it will still try to run through all the rows. But if you do some clustering here, let's say on the country, and you have said that in the where clause, I just have US, it will not try to run everything. It will just try to run this particular part in the table. If you have added the partitioning and clustering, this is how your tables would look like. So this is one whole table, but now it has chunks of data in there. So when I say select star my table, where the date is so-and-so and the country is, KE, it will just, read only 2 rows as opposed to like the whole table. This way you can, optimize your queries. You always can mention your conditions in the where clause, and it will only try to find those rows which meets those conditions. So this way, wherever you can find, try to implement partitioning and clustering as well on your tables. Remember, partitioning is always on dates, and clustering is always on those string type of columns. Another thing that we can talk about is reservations. So if you've seen the pricing model for analytics in terms of compute, there are two. By default, we have on-demand pricing, which will just, see how many slots are available at that time. So it just goes up to 2,000 slots, tries to run your query at least amount of time that's possible, and then return the results as soon as possible. This is turned on by default, and you can get much unpredictable cost there. But there's another option. So if you like a very consistent and predictable cost every month, you can switch to this particular version, which is flat rate pricing. So let's say for 50 slots, you want to just have it's $1,500, and your team is just a small team, which is 2 people. You don't want to have you don't have much usage. You can just buy certain slots. and you know that you're going to pay a definite amount of money per month. So that way you are committing to certain flat rate pricing. You are committing to a particular BigQuery slots. That's the term that Google uses. So for your particular use case, you can see like how much slots you're using for your project, and and then determine if you want to switch to this particular mode of pricing where you have predictable cost every month. You do have to know there's a bit of caution if you have a lot of people on your project and all of them are working and querying at the same time. It might take a bit more longer to run those queries during those peak times because everyone is sharing those slots at the same time. Now, if you want to estimate the slots based on your usage, you can go to capacity management functionality within GCP. So at the very top in the search bar, if you just type capacity management, you will see the screen where you just can see everything regarding slots. You can navigate to this particular tab, which is slot estimator. And if you look at that, you'll see your usage in terms of how many slots your team are using every day. And then you'll have a chart. So with this, you'll understand how many slots you can use. So if you look at this chart closely, the average slot usage is around 1,700 or so. So if someone just buys 2,000 slots for that team, I think it should be good enough for that team because that's the most average usage here. So with this particular charts that you have within BigQuery, you'll be able to understand what slots work best for your team, how's the average usage across all the days that you have, and then you can determine which works best for you. Once you switch to that particular pricing model within BigQuery, you also can see how your queries would function with respect to different slot options. So if you go and you say like, let's add some more slots in there, but you want to see how it affects your average job duration, you can also see that particular table in GCP that notes down what the % difference would be in terms of performance. So it will try to calculate the number of jobs that you have on a project and will determine what the average job duration would be. So this is pretty cool in terms of seeing how your jobs would run and what the average job duration would be. This is another optimization. I think this was very recent, like last year, October, Google released this feature, which is history-based optimization. Essentially, what it will do is it will try to learn from your similar queries that it has in your project, and it will try to find some improvement in your queries that will enhance performance. Mostly what it learns is in terms of joins, how to do different joins. If there's any way to reduce the amount of processing needed, if there's any ways to reduce the number of rows being captured, that's what it does. If you want to turn it on, it's pretty simple. If you just, copy this particular code in your project, paste it into your editor, change location and project name, you can turn it on. So as long as like you have this alter project added in there, it will be turned on and it will automatically start in changing and optimizing your queries and try to run it faster. You can turn it off anytime as well. All you have to do is in this particular case, you just have to say adaptive equals to off and it will turn off that feature. So it's pretty easy to kind of turn it on and off. You should, make sure that there are certain things that are changed in your queries. So there's a whole lot of detail available on this page. So when you, if you click through this particular hyperlink, you'll go through that article, which will explain everything about this history-based optimization. When Google was trying out this particular method, they observed that, in the very starting of the query, it was using like 60 minutes consumed, but there are some iterations that it goes through. So it will try to apply something in the first iteration, second iteration, and then it will try to find the most optimized versions in terms of query processing. In detail, if we kind of look at what that optimization is, it's like 4 types of different performance improvement. It will try to look down for like just understand the joins that are happening in your query. It will try to understand the order of joins and then see what joins make more sense at what order. So that this join pushdown is doing the same. It's trying to order it in such a way that it's trying to reduce the amount of processing it does. There's also semi-join reduction, so it will insert semi-join operations in between, and it will try to reduce the amount of data that's being processed. So in this particular chart, you can see that same, where it's trying to add their own semi-join so that you have 2 different tables here instead of 1, and it will try to like reduce the amount of data. Also, swapping the left side and the right side of join operation sometimes works wonders. So it will try to do that and see if it reduces the resources consumed in any way. And then while we are doing all this, it will also try to see if there is any way that it can parallelize all of this work. So it's very useful if you have a very large compute heavy queries. It will try to like look for all these type of optimizations, and then it will try to determine which works best for your query. So try it on for one of your projects and see if it makes sense to implement this for your work. The next one is storage type and time travel. So within BigQuery, you will see there are 2 components. There's something known as like if you go to like your data set level, you can click through those options, and in the advanced option, you see 2 specific things, which is storage billing model and time travel window. By default for the storage billing, you always have logical storage in, which is decompressed data. It will have everything like field safe, travel storage, everything is included within those model. And currently you are being charged with logical storage. But if you find that there are certain data sets where data can be compressed, you can switch the physical storage mode, which is actually just making sure that we have the same data. It doesn't affect the query in any way. You can still query the same way. It's just that in physical storage, your data will be compressed, but it does not have any time travel capabilities. Now, talking about time travel capabilities, it's very useful. I have used it in my projects as well. I've accidentally deleted some data, and I wanted to make sure that I am able to recover those data. And in that time travel is very useful. You can go back to the previous versions of your table. If you want to restore certain versions, you can do that. You can make sure that you have everything in there. You can go back to previous snapshots and then retrieve it. So this is pretty useful if you want to do that. But by default, you have this 7 days window. So you always, can go back up to 7 days and find a snapshot that works for you and restore it back. But you really don't need that much. Imagine all the data sets and all your tables having 7-day snapshot. If you reduce it to 1 day, you can significantly improve your cost. Talking about, physical storage, if you look closely in the pricing model for physical storage, the cost is almost the double of logical storage, but there are like cost benefits to it. If you run a detailed analysis on all your data sets and you see how compressed data can be, so there is a query. So this query, if you click on this hyperlink, there's a query that you can run to understand how much data is being there, is in the active storage versus what is in the long-term storage. And if you switch from logical to physical, how much cost savings you would have. But you have to really closely look at the compression ratios. So if you have around 16 to 25 in this particular example, compression ratio, you can actually have remarkable cost reduction of 8 times. but it really depends on the compression ratio. If you have anything less than 2, then it doesn't make sense to switch to this model. You should have high compression ratios to benefit from that. Also, time travel is categorized as active storage, and that is, that is taking up a lot of cost on your end. So always try to see if you can reduce the time travel window, and if you want to find out like what's the optimal, compression ratio for your tables, and if it's worth switching to the logical storage, we can definitely do that. Okay. This one is pretty useful, and I would say the most important ones is to introduce a semantic layer. Whenever you have BigQuery and your end application, make sure that you always think of layers in between. So if there is a way for you to store your data or like store your results of your query in a table and then retrieve it onto your end application, that's pretty useful. So let's think of dashboard here as an example. I have a query which runs on, and then I want to have that in dashboards. But if I have 4 or 5 people on my team and they run the exact same query to see that chart on the dashboard, you will run that, you will have 4 times the cost for that same query. And that's why it's very important that we cache this data in some way. So introducing layers of tables in between is going to be super useful. There is caching done in BigQuery on the user level. So let's say if I have a query and I run through it, it will be stored as a temporary table in BigQuery, and I keep on running that table query again and again today. It won't give me any more extra charges. It will, run the same cache data. But if that query is being run by some other person, they will incur the cost. So for this very same reason, if there is something which is very repeatable, if you can, have data on, or if you can dial down or reduce it to particular scope, you could have session scope, table, you could have product scope table, and then you want to combine it and make another table that will work for your dashboard. That's a different layer of semantic layers. So that's pretty useful. We have another webinar which will talk more about it. She will definitely, walk through the lookup part as well. But within GCP, there is a free product that you can use, which is pipelines. Previously known as data form, they have both these names right now in UI. So you could see that this tool is pretty useful to kind of build all of that logic and store it into GitHub so that you have all the logic in there. You can see the lineage as well, as like these are my individual tables. This is what a source table is. This is how the staging tables look like, development looks like, production runs look like, and you can have like a mini chart showing the flow of data. So it's pretty useful. Do check it out. It's free. You just incur the BigQuery storage and compute cost on top of it, which you can like use it for all your different end applications. So think of it as a mini GitHub repo for your SQL stuff that you can save it in data form. The last one for optimization is incremental strategies. Once you have all these tables built up, it is very important how we make sure that like the table is refreshed. So make sure that you're only refreshing the net delta there. We don't have to, replace the entire table again and again. We can just make sure that we have those deltas between maybe today's and yesterday's data, and then take in all of that into our tables. That way you can have, you can save cost and storage, and now you have all those tables refreshing in your data form or in your BigQuery, and it's only refreshing for those deltas that you have between your base table and your newly created table. So doing that, it will significantly improve the performance, lower the cost for making sure that your tables are refreshed. All right, so it's time for poll. Take a little break. If you want to sip coffee or water, please do so. But we have a few more things. All right, so let me run through the next things. So there are some more things that you could do for cost controlling, and it's administrative piece. So think of like placing budgets or creating alerts for your BigQuery's cost. So the very first thing that you could do is you can set up a quota limit. Right now, by default, you can run unlimited data and you don't have any terms of like policy to see how much you can use. But if you want to change that, if you want to set up a particular quota on your project, you can do that. So there are two levels at which you can set up the quota on project level or on user level. So you can say, for this project, I just want people to use, let's say, 5 TB of data. That's it. So you can mention that here in your, quotas page that is available in BigQuery with that BigQuery API page. So you can adjust your quotas for project or for users in your project right now. There's another thing that you could do is restricting billable bytes. So you could say in my query, if I run any query, I don't want it to run more than 5 GB, anytime. So as soon as someone writes a query and it takes more than 5 GB to run that, it will automatically give you an error message and say this is exceeding the limit, you cannot run it, you don't have it doesn't incur any cost. So that way you can set up some limits on your end to make sure nobody runs a very large query on your end. And you always have the error message before you try to execute it. So this is very useful, especially if you have a very large query being run. The third one is creating alerts and budgets. So here you can, in GCP, you can have budgets created. You can also have alerts created, like 50% of, budgets has been used, something like that. And you can get email notifications for that too. You can automate all the processes or your like responses after that. So for example, if you have a budget set for a month, and you are using 50% of the budget within the first 2 days, you can have an automated responses to your team, making sure that you understand whether to increase that budget or optimize some of your queries or something like that. So these are pretty useful. These are things that you can definitely implement on your GCP. It's very quick. In terms of recommendations, what we would really recommend is first you start with quick wins. So making sure that you're using the right querying techniques. You're using table sample, you're using table suffix, everything that you need in the development stage. And then when you're good, then you can move on. You can start like using just 1 day's worth of data, build up your query, make sure that you're doing all your QA on 1 day. And then when you feel like your query is ready, you can move it to production stage, and then you can run it for the whole time range. Create a table. That way you're saving that work into a table and then referencing it that way. You can turn on the historical based optimization. It's pretty easy to write that alter query in there and turn it on so that it tries to learn from the optimizations that are available. And you can reduce the time travel duration from the default 7 days to 1 day, if that works for your team. I know all the different teams have different preferences, but I think 1 day should be enough for time travel. So that's going to be pretty useful and quick win. You can see the cost reduction would be great. Then when you have all of this ready, then you can go to monitor and evaluate stage, where you can set up administrative cost control. You can limit, quotas on project level or user level. You understand your average usage in terms of storage and cost, understand which data sets have, more compression rates, where you can try to evaluate if you want to use physical model for your data sets. Try to use partition and clustering whenever possible. So if you have any new tables that's being created, for sure mention partition if you can. Sure, have clustering also added in there. For previous tables that you have already created, which doesn't have that, you can rerun them again and make sure that partitioning is being added so that next time you use those tables, you are only referencing certain pieces of your table. You're not like reading through the entire table here. And once you're comfortable with that, then long-term strategy, you can think of, building semantic layers. I think that's very important. You want to make sure that you have a structure in your mind which will work for your end application. If there is a base table that you can build, if there is an aggregated table that you can build on top of it, you could have like multiple layers of tables before you reach to the end application. So look for that. Data form is definitely great. If you don't want to start with that, you can use BigQuery. Just have it simple right now, just having tables in there. But then long term, if you are building a solution for your team, look for data form. It's free. You don't have to pay anything extra. You just save all your work in GitHub. That's an added bonus if you have whole team working on a solution. And then also switching to reservations. If flat rate pricing is great, you can do it on different levels. You can maybe commit it on monthly level, yearly as well, if that is feasible. You can contact Google and see what makes more sense for your team. And then definitely switching to incremental strategies while loading table. So these are the things that you could do in terms of optimizing your BigQuery. So I'll now pass it over to Jared.
Awesome. And with that, we have another poll. So the question is, how would you rate your current BigQuery optimization skills? Was this the first time that you've heard about it, or have you heard about it, learned about it many times before? So feel free to continue to submit those poll responses. With that, we will roll into some resources. We'll continue to keep that poll up for a little bit. We can go ahead and jump into some InfoTrust resources that y'all have. So first and foremost, Trish, if you'd like to jump to the next slide.
Yes.
Perfect. Upcoming webinars. So we have a few other upcoming webinars, one actually a week from today. So if you are currently looking to mitigate your privacy compliance risks, we certainly recommend you joining. Tag Inspector is one of our proprietary solution products, primarily targeting data governance, as that is something that is very important to be aware of. We don't want to be passing any kind of PII or sensitive data that's not meant to be passing, that might be breaking laws and cause any sort of fines to occur. So definitely feel free to go ahead and join that one. And then also the continuation of this BigQuery unlocking series. We 100% want other people to join this. So if you have any colleagues that would be interested in this, as Trish made a few mentions to the next webinar around visualization and reporting and insights with BigQuery, definitely go ahead and join us with Nina presenting, one of our visualization experts that does many different visualizations. And then even beyond that, how do you actually activate on your data? We hear a lot about, now we have all of this data, how do we actually activate it on it? Go ahead and join Shaz, as she will be presenting AI-driven data activation with BigQuery and Vertex AI. That's another buzzword, AI. How do we actually integrate that? Maybe you're hearing from your CMO or your management that, hey, we need to start working with AI. Well, how do we actually take a logical step towards using that in our organization? We'll kind of be helping answer those questions. That will be on April 3rd, so here in a couple months. But that's kind of a highlight of webinars. Obviously, we'll continue to have more and more webinars continue to come out. And so just keep an eye out for that. Also coming up soon, we have AdTech Unlocked. So if you are in the London area, or if you want your company to pay for you to go to London, definitely go ahead and join us on April 24th. This will be a half-day event where we will be hearing from industry experts, or actually it's kind of more of a full-day event. where we'll be hearing from industry experts, not just InfoTrust industry experts, but also those brands that I showed earlier that we work with. Some of them will be presenting. And so we are very excited for that. So if you are interested, this will be in London at Google's Central St. Gal's offices. So definitely go ahead and join. It might be a easy way to go see Big Ben, go to London, enjoy some time out there, or anything along those lines. So primarily that's for y'all EU folks. But if you're in the US and you want to go ahead and go out there, definitely go ahead and sign up. If you are a client, one note here, go ahead and reach out to your project lead that you're working with. So anyone from InfoTrust, or you can also reach out to your partnerships lead, and there will be a special code for y'all that will actually get you in the door for free if you're interested in doing that. Lastly, I kind of mentioned a little bit earlier, there is a resource hub. So if you are interested in jumping your resource hub, oh, and also all of these are clickable as you just saw there. So all of these images are clickable for you. So if you're interested and you get this deck, click on that link, these links that are in there. But as for the next slide, we will see the resource hub. So we always love coming out with new resources that help both clients and prospects alike, because one thing that we believe in is continuing education is going to lead to long-term benefits. So if you're looking for ways to advance your analytic techniques, privacy-centric techniques, data governance, whatever you're interested in, media enablement, go ahead and check out the Resource Hub. We're always coming out with new webinars such as this one, as well as articles. We have a few books out there and everything along those lines. So definitely go ahead, check that out, and look into that. So now what everyone is waiting for, the Q&A. So Trish, we have a few questions for you. The first one being, if I am querying a BigQuery table or view from a visualization tool like Power BI using a method like direct query, as opposed to importing data, is there a way to monitor compute costs associated with those queries?
Yes, absolutely. This is a great question. So, within those word itself, you'll get a clue. If it's direct query, which means it's running the query directly on the BigQuery end, and then it's trying to give that results into Power BI and then supplying there. So anytime you have anything running on the BigQuery side, you can definitely, see what those jobs are. You can always also look at like how much data was being used in those jobs, and you can monitor that closely in your dashboard. So that GCP has that dashboard as well, where you can see how you're incurring cost for each queries. So whenever you're using direct query, you can see the jobs in BigQuery, and you can also monitor your compute cost with that.
And also, I know you said visualization and Power BI and everything along those lines. Join us for our next webinar on March 6th with Nina. So, all right, the next question is flat rate pricing limits our slots, correct? Thus, will the query speeds always be the same as compared to on demand? If not, which reservation option will optimize speeds based on our needs?
Yes. So when we talk about flat rate pricing, it is slots, and correct, it is BigQuery slots. So let me go back to that slide which we had for understanding slots. So it's a very good question, and you can like see here that you do have like slots on how much you're using it. So if you have multiple people working on your project, you will see your queries might take slightly more longer to execute because it has limited capacity right now. It won't be as same as on demand, because in on demand, it will try to find as many empty slots as it can see. So it can go up to 2,000 slots and try to process your data. So definitely in on demand, it will always be fastest. On flat rate pricing, it will be a little bit slower because you now have constraints in terms of how much slots you're using. So that's why whenever you have like 100 or relatively steady, usages, you can see like, oh, run your query for like 4 minutes, 5 seconds, versus if you add like just 200, it would be, some more seconds here. So make sure that you first understand your, usage. You understand what number of slots make sense for you. With that, the speed as well. So you can see on your end within GCP itself, these calculated metrics. So always also like try to understand how your performance will change with the different slot options that you have.
Trish, can you just do a really quick summary over that? I believe that you froze just a little bit, maybe
Okay.
there's some internet thing. So can you just do a really quick summary, just what you just went over there?
Sorry. So yes, flat rate pricing is definitely BigQuery slots. So you buy a certain amount of slots for a particular month. So your performance will be impacted. On-demand pricing will always have the most fastest speed available for you because it's trying to like find as many slots as it can at that point of time and returning you the results. Versus in flat rate pricing, it only has like certain slots. So if you have just 50 slots, and you have like 5 people working on it, your query will take a bit more longer to execute than just one person working on that 50 slot. So it really depends, like how much resources you have right now in those slots, but it will get slower at that point. If you feel that that speed is too slow for you, you want more faster speed, you can try adding more slots. So if you think about, adding more 200 slots or like adding more 500 slots, this is the comparison that will help you in understanding what the speed should be.
Appreciate it. Um, and then one of the last questions, just as we start hitting time. So is it a good approach for BigQuery to use a sandbox while creating the query for future use?
So sandbox are generally those versions where we don't have any credit card added. Um, so in terms of development, it doesn't really matter if you use the sandbox version or the paid version of BigQuery. What would really help is limiting the amount of rows as much as possible. So you can say, like for my development, I just want to use, sample data, or if I want to just use 1 day's data, try to limit how many rows I'm scanning in my table. And then once you're good with that, then you can move to the bigger time range. It doesn't matter if it's sandbox or not. Um, it's what matters is how many rows you are, reading through or scanning through while computing your queries.
Well, appreciate it. And if there's any questions that weren't answered, I know there's a few that are open right now that were submitted. We will certainly reach out to, if you're a current client, your project team, and get those answers to you. If you are not currently a client, we will certainly also go ahead and reach out to our partnership team and make sure we get those answers over to you. We want to make sure that the answers are all answered per se. But with that, we have one more poll that popped up. So would you like to have a follow-up conversation to discuss your organization's BigQuery cost optimization? We really appreciate y'all joining today, so feel free to submit that question. And also, if you're a future client, go ahead and reach out. Infotrust.com contact us. That is the way that you can get to us. If you just look up InfoTrust, you'll certainly find us as well in any sort of browser. And if you're a current client, definitely go ahead, reach out. If this is something that you have been finding as an issue, go ahead and reach out to your project team and request a workshop. We like putting on some workshops for our clients so we're able to showcase some of the value, especially regarding today's topic around BigQuery cost optimization. With that, it's signing off. We hope to see you in the future. Feel free to sign up for anything. Take care, y'all.